Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem. So the very first thing we are going to do is I can write 8 as, here we have 2 to the power of x. We can write 8 as 2 to the power of 3 and its whole power x is equal to 68. So in this question, one thing you remember is that we will find real solutions. Okay, here we find all the real values of x. So if we have any complex or imaginary value, then we will neglect it. So now we move towards the solution, and here we will rearrange this term. And you know that in exponent law, if we have x to the power of m to the power of n, then it will write it in this form: x to the power of n to the power of m. Okay, so just I will interchange its exponents and I will write this term on first. So it will becomes 2 to the power of x cube plus, now we write the first term, 2 to the power of x is equal to 68. Now I take y is equal to 2 to the power of x. Here I take 2 to the power of x is equal to y, and this expression will becomes y cube plus y is equal to 68. I will name this as 1. So now I will rearrange this term and I will obtain y cube plus y minus 68 is equal to 0. And now I will write this y as minus 16y plus 17y minus 68 is equal to 0. Here I will check that when we can subtract minus 16 by 17, then it will becomes plus 1. So here I can write this y as minus 16y plus 17y minus 68 is equal to 0. And here you can write any number which is divided by 68. So here I can write 17 here. Okay, so now we take common y and we will obtain y square minus 16 plus, here we take common 17 and we will obtain y minus 4 is equal to 0. And now we again write y square minus 16 as y minus 4 times y plus 4 and plus 17 times of y minus 4 is equal to 0. Now we take common y minus 4 from both of the terms and we will obtain y times of y plus 4 plus 17 is equal to 0. So now we have y minus 4 is equal to 0, and here we multiply this y on both terms and we will obtain y square plus 4y plus 17 is equal to 0. And here we will get y is equal to 4, and you can see that we substitute y is equal to 2x. So I will back substitute the value of y and I will get 2 to the power of x is equal to 4, and we will write 4 as 2 to the power of 2. So now we will write, so now when you compare both sides, then you can see that bases on both sides are same and its exponents are equal. So we get x is equal to 2 be the one solution of the given nice exponential equation. Okay, so now we first we check how many real solution of this quadratic equation exist. Okay, so here you can see the famous discriminant formula, which I can write it as delta is equal to b square minus 4ac. Okay, this delta will know about how many real roots of this expression are exist. Okay, if this delta is less than 0, then we say that its roots are complex or imaginary, and if this delta is greater or equal to 0, then its roots are real. Okay, so here we substitute the values of a, b and c, and we check that how many real roots are exist or not. So here you have the value of a is 1, the value of b is 4, and the value of c is 17. So now delta will becomes, when we substitute b square by 4, then it will becomes 4 square minus 4 into 1 and 17, and here you get 16 minus 17, 4s are 68, and 16 minus 68 will becomes minus 52. Okay, so our delta will becomes less than 0, and so here we can say that the roots of this quadratic equation are complex roots. So we can just neglect this term, because our question is that here we will just find the real roots only. Okay, so this quadratic equation gives the complex root, so we will neglect it, and here we have only one solution of the given exponential equation, and which is x is equal to 2. Okay, so thank you so much for watching this video. Please subscribe my channel for more exciting videos.